Hi friends, I welcome all of you to my chemistry channel. Today's video is about important topics in physical science. I know that many of you are trying to clear IIT-JAM exam in a chemistry with good marks, and I'm sure that, believe me, this video will going to highly help you to score excellent marks in a IIT-JAM chemistry. So let's start our topic. Friends, when you look at the syllabus of physical chemistry, one thing you'll realize surely that topic is vast and syllabus is big. But at national level, if you want to compete and you want to score good marks, you have to plan in a systematic manner. And in this video, I have brought you the topics of physical chemistry in a systematic manner. So let's start a step by step. First topic that is very important, that is called atomic and molecular structure. In that, we have Pauli's exclusion principle, Hund's rule and above principle, Slater's rule, Planck's black body radiation, photoelectric effect, Bohr's theory, de Broglie's postulates, Schrödinger wave equation, Heisenberg uncertainty principle. The postulates of quantum mechanics normalize an orthogonal wave function, operators and particle in one-dimensional box, radial and angular nodes, energies spectrum of hydrogen atom, significance of psi square, and the next topic is the shapes of S, P, D and F orbitals. So these are the points generally covered under the heading of atomic and molecular structure. Next topic is gaseous state. Here, the kinetic molecular model of a gas, collision frequency, collision diameter, mean free path, and viscosity of gas, Maxwell-Boltzmann distribution, molecular velocity, law of equipartition of energy, and heat capacities, ideal gases and its deviation, van der Waals equation, critical state, and a law of corresponding states. These topics are there under the heading of gaseous state. Then next we have liquid state. Here we need to read physical properties of liquid, vapor pressure of liquid, the surface tension and coefficient of viscosity and their applications, how the concentration of solute affects the surface tension and the viscosity properties of liquid. Then we have the effect of temperature on viscosity. Next topic is the solid state chemistry. Here the unit cell, Miller indices, crystal system and Bravais lattices. Next we have X-ray diffraction, that is called XRD, and Bragg's law. This is very important topic in solid state. Later we need to read the structure of NaCl, cesium chloride, potassium chloride, diamond and graphite. Close packing in the metals and metal compounds, semiconductor, insulator and defects in a crystal. Afterwards, lattice energy, isomorphism and heat capacity of solid. And these are the important parts in the solid state chemistry. Next topic is highly important, that is called chemical thermodynamics. And my dear student, every year you will see 4 to 5 questions only comes on chemical thermodynamics. So read this topic very carefully. Let's start. Here we need to come across law of thermodynamics, reversible and irreversible process, thermodynamic function like enthalpy, entropy and Gibbs free energy, their characteristics and their applications. Furthermore, you need to read partial derivatives and Euler's rules as well as cyclic rule, Gibbs-Duhem equations and partial molar quantities, and chemical potential and its application. So I humbly request all students, please try to solve the numericals and theoretical aspects of thermodynamics, because this is a very important aspect in physical science. Later, we need to read the chemical and phase equilibria. In this topic, there are various equilibrium constants are there like Kp, Kc, Kx and Kn. These are the concentration of equilibrium reaction in terms of pressure, concentration and so on. Then we have Lee-Chartier's principle and solubility product, that is called KSP. Next is pH of solution, buffer solution and the indicators. Raoult's law and Henry law, Gibbs phase rule and colligative properties. These parts you need to read for chemical and phase equilibria. Afterwards, an important topic is electrochemistry, and you will see 2 to 3 questions are regularly coming on this part. Here, the conductivity, equivalent and molar conductance and its variation on concentrating solution and the diluting the solution. That means the variation of conductivity and molar conductivity on dilution. This is a very important concept. Later, you need to read the Kohl's law, Debye-Huckel-Onsager equations, transport number, applications of conductance and EMF measurements, Faraday's law of electrolysis, Nernst equation and electrochemical series, and next and last we have conductometric and potentiometric titration under the heading of electrochemistry. Next important topics we have with us, that is called chemical kinetics. In this, order of the reaction and molecularity of the reactions are important. Furthermore, the differential and integrated form of rate expression like steady state approximation, then Lindemann mechanism and Michaelis-Menten mechanism, Arrhenius equation and how the temperature, the catalyst amount, reactant concentration, how we change the rate of reaction, that part we're going to cover in Arrhenius equation. Collision theory of reaction rates, types of catalyst like homogeneous, heterogeneous, metal-based catalyst and so on, and acid-based catalysis. These are the part are there in chemical kinetics. Next we have adsorption concept. Here you might have come across adsorbate, adsorbent and so on. In this Gibbs adsorption equation, here you need to read the how the pressure of adsorbates affect the adsorption extent and how it affected also by temperature of the gases. Then we have various form of adsorption isotherm such as Friedlich's adsorption isotherm, Langmuir adsorption isotherm and Brownier-Emmett-Taylor, in a short form we call BAT adsorption isotherm. Then we have the types of adsorption and surface area of adsorbents, surface films on liquid. So these parts are important under the heading of adsorption chemistry. And at last we have very important topics of chemistry, and it is useful for organic, inorganic, and physical sciences, that is called as a spectroscopy. Here, the Beard-Lambert law is very important, and in this part we can get a numerical question on Beard-Lambert law. Next we have magnetic resonance spectroscopy. It is called NMR technique. And next, ultraviolet visible spectroscopy, which is also known by different name, that is called as a electronic spectroscopy. Then we have infrared spectroscopy, also known by a different name, vibrational rotational spectroscopy. And at the end, my dear students, we have microwave spectroscopy, also known as rotational spectroscopy. So if you look at the complete syllabus of physical chemistry for IIT-JAM chemistry, this video is providing you a systematic way how you can read your topic, and I am strongly believe that if you go through all the section, main section and subsection, you'll going to score good marks. So with this, I'm going to stop here, and I'm giving you best wishes for your IIT-JAM exam in a chemistry. That's all. Thanks for listening to me. Signing off, Dr. Atul Nagpure.